continue to modeling OC slab model slab on beam. Each direction 90 degree. We design the slab to west slab, include diaphragm, dip. You can override dip, overall dip. Check in a structural plan for the second floor. Overall dip 120. For other slab thickness, we will correct it later. We will use override to correct this slab. Now set the dip to 150 mm. Overall dip. Concrete use 30. Reinforcement we use top and bottom reinforcement. FY 500 MPa. You can change the bar spacing. Now I keep in the default 200 mm. Top cover and bottom cover keep it 30 mm. Okay. Click. Click. For the slab, you can model it at the same with architectural plan, but for structural analysis and design, I do not recommend you model everything at the same with architectural plan. Simplify it by modeling at the intersection point beam. Now we have the slab here. You see here slab. If you want to model this structure the same with architectural, I will show you. Yeah. If you want to model everything the same with architectural plan. But I do not recommend you model everything at the same with the architectural plan, because in structural analysis you should modeling in node. Yeah, node transfer load. The intersection between beam and beam is a node. Very important. We want to model it correctly to avoid any error occur during analysis and design. So come back. I just click on node. Okay. Or you can click on the first node to the last node, no matter. So I ignore this slab. Click. Escape. Complete modeling slab. Click on validate to check any error. Model. General. Click highlight member intersection. Okay. Right now we have to switch the member intersection. Now change. Okay, again. Model concrete beam. Use the section to 20 multiplied by 40. Click enter. Click enter. Validate again. Member intersection. Yeah, delete this beam, or you can split it. Model beam. Click enter. Member validate. Okay, now split this beam. Edit, split, select, model, validate. Member may not be supported as intended.